Hello everyone, so today we will learn about bridge design pattern. This is one of the structural design patterns which are concerned with how the classes and objects can be composed to form larger structures. So according to bridge pattern, we can decouple an abstraction from its implementation so that the two can change independently. Its main objective is to prefer composition over inheritance because as you know, once we inherit any class, we cannot inherit any other class. Two main parts in this pattern are abstraction and implementation. Main point of access for the client would be the abstraction part and the implementation would be inside of an interface. The abstraction would then contain a reference to the implementer which would act like a bridge between the abstraction as well as the implementation. Suppose we have a device, right? We have an abstract class device which is having some abstract methods turn on, turn off and set channel. So whatever the devices are extending this device class, they have to provide the implementation of this abstract methods, either turn on, turn off and set channel. So consider we have two such devices, one is TV and the other one is radio. Okay, so we have a TV. Okay, so within that TV we have a remote, object and we are providing the implementation of the turn on, turn off and set channel methods. So within the turn on method, we will use this remote and then we will turn on. Okay, we will call the turn on method in the remote class and we will call the turn off and the set channel. Right. So this is the remote class which is having the three main implementations of this method. So this might do some internal operations and then it will turn on the TV or it will turn off the TV or set the channel. So similarly, we have another device, right, radio. So radio is also a device which is extending this device abstract class. So within radio also we have this remote and then we have the implementations for this turn on, turn off and set channel. So now if you take a closer look at these, okay, turn on, turn off and set channel is something which is like the implementation of this abstraction, right? So this is something like the implementation of this abstraction. So in that case, what we can do is we can completely separate this implementation. So suppose now tomorrow you like your TV has some advanced features and you want that remote, okay? So you want this remote to have that advanced features. Okay, something like increase the volume or decrease the volume, though they are not the advanced features, but still let us consider that. Or some recording option we have, right? So we have that advanced options, but we do not want this radio to have that options, right? We do not want like our radio is still not advanced yet. So we do not have those options over here. We don't want the remote of this within this radio to have those options. So this is something like which it doesn't look right. Right. So this remote which we are using commonly for both TV and the radio to perform the implementation of the methods. Okay, these are the methods we are implementing and these are the methods defined in our device, right? We are providing the implementation of these methods within remote, right? So, and that we don't want to have it common across all the devices. Okay, we do not want all the devices to have the similar implementation of these methods, right? So in such scenarios, what can be done? So what we can do is we can separate this abstraction from the implementation. And how we do that is by using this bridge pattern. So we will have another interface here. So let us consider some interface remote that would act like a bridge. Okay, so we will have this interface I remote which will have the implementation of this methods, okay, the objects of which will have the implementation, specific implementation of this turn on, turn off and set channel. Okay, the actual device would have these methods, but the implementation logic we are taking it out to another interface. Okay, the abstraction and the implementation we are separating it out. So then what we can have is we can have another class which is implementing this interface, something like TV remote, right? So now we have our special TV remote which is implementing this I remote, and for radio we will have another remote, okay, that is having radio specific remote operations, right? So now we have completely separated the implementation part for these devices, okay. So now instead of this remote, what our devices will have is, so instead of here common remote, we will use a TV remote, right? Instead of the common remote, we will use a TV remote. And let us create the object here, or let us make this as I remote, and we will create a TV remote here, right? Similarly, in the remote, in the radio device also, instead of remote, now we will use this I remote. Now this I remote is acting like a bridge, and we will create the instance of radio remote here, okay. So now isn't it the same thing, right? Instead of now the common remote class which was common for all the devices, we have the implementation of this remote separated, segregated from the actual implementation, right? So now we have this bridge, and we have separate TV remote and the radio remote specifically for these two devices, correct, TV and radio. So this is nothing but a bridge pattern, so where we have the abstraction and the implementation logic separated.
The main advantages would be obviously loose coupling between the abstraction and the implementation can be changed at runtime. This pattern is used for implementing features like platform independence. If you like this video, hit the like button, subscribe to my channel, and hit the bell icon to get notified for the next videos. Thanks for watching.